Tutorial 8, question 4. Integrate 4x minus 6 over 3x squared minus 7x plus 4. Whenever you see an integrand that's got a function of a power of x over another function of a power of x which is one order higher, you're going to use partial fractions. So the first thing we want to do is to factorise the denominator. So 3x squared minus 7x plus 4 can be factorised as 3x minus 4 times x minus 1. Let's expand it to make sure that that's correct. So 3x times x gives us 3x squared. 3x times minus 1 gives us minus 3x. Minus 4 times x gives us minus 4x, so that's minus 7x, so that's correct. And then we've got minus 4 times minus 1, which gives us plus 4, so that's correct. So now let's look for two coefficients, a and b, such that the integrand can be written as a over the first factor plus b over the second factor. Let's put the right hand side over a common denominator. Now we can cancel the denominator on the left hand side and the denominator on the right hand side, so our equation now becomes 4x minus 6 is equal to a times x minus 1 plus b times 3x plus 4. What we'll do now is we'll let x equal 1, so that bracket will disappear, so we'll have an expression only in b, and you can see quite easily that b is equal to 2. Then we're going to let x equal 4 over 3, so this part becomes 4 minus 4 is 0, so this bracket will therefore disappear, and we'll get an equation only in a, and you can see that a will equal minus 2. This is a time for a sanity check just to make sure these values are correct, so we'll replace a with minus 2 and b with 2. Expand these brackets, so we're going to get minus 2x plus 6x, which gives us plus 4x, and we're going to get plus 2 minus 8, which gives us minus 6, so that's correct, and we can continue. So the integral now becomes the integral of minus 2 over 3x minus 4 plus 2 over x minus 1. These are both of the form 1 over a linear factor in x, which means that the answer is going to be a log of the denominator divided by the differential of the denominator. So the first part will become minus 2 log 3x minus 4 divided by 3, because 3 is the differential of that denominator there. The second one will become 2 log x minus 1 divided by 1 in effect, so we don't need to write that. So I'll just tidy that up a little bit, and there's my answer. Differentiation is easy, integration is not. So every time you've carried out an integration, make sure you differentiate your answer to be sure that it's correct. So let's do that now. We're going to differentiate 2 log x minus 1, which is going to give us 2 over x minus 1, and we're going to differentiate 2 log 3x minus 4 over 3, which is going to give us 2 over 3 brackets 3x minus 4 times the differential of the bracket, which is going to be 3. We can cancel the 3 on the numerator and on the denominator, which means we've got a simpler expression. Put this over a common denominator, expand the brackets. We've got 6 minus 2, so that's 4x. We've got minus 8 plus 2, so that's minus 6. There's minus 4x plus 3x there, so they become minus 7x, which is the expression that's just hiding there. So we've got that correct. Part B. Our approach is going to be effectively the same as in part A. So let's factorise the denominator. So 12x squared plus 2x minus 4 is equal to 3x plus 2 times 4x minus 2. Let's expand the bracket just to be sure. 3x times 4x is going to give us minus 12x squared, so that's okay. 3x times minus 2 is going to give us minus 6. 2 times 4x is going to give us plus 8x. Plus 8 minus 6 is 2x. And then we've got 2 times minus 2, which is going to give us minus 4, which is the same as the denominator, so we're good to continue. Okay, let's look for two coefficients, a and b, such that that expression becomes true. Put the right hand side over a common denominator, cancel the denominators on both sides because they are in effect the same. So we've now got an equation. Set x equal to a half, so that bracket will disappear and we'll have an equation only in b, and so b is equal to 5 over 7. Not quite obvious, but work it out if you don't believe me. Then we'll set x equal to minus 2 over 3, so that term becomes minus 2, the bracket becomes 0, so we've got an equation only in a, and if you do the arithmetic you'll see that a is equal to 17 over 14. Substitute those into that equation for our sanity check. If you work through the arithmetic you'll see that the equation expands to 7x minus 1, which is 7x minus 1, what we've got in the numerator there, so that's good, we can continue. So the integral now becomes 17 over 14 3x plus 2 plus 5 over 7 4x minus 2. Obviously that's going to be 17 over 14 log 3x plus 2 divided by 3, the differential of the bracket. I'm going to take a 2 out of this bracket here, so I'm going to get 5 over 14 2x minus 1. So the integral this time will be 5 over 14 log 2x minus 1, and then you divide by the integral of the new bracket, which is obviously 2. Tidy that up a little bit, and there's our answer. Time for a sanity check, so we'll differentiate that answer, giving us the differential of the expression in the bracket, which is going to give us 17 over 42 brackets 3x plus 2 times 3, because that's the differential of the bracket, plus 5 over 28, 1 over 2x minus 1, and then times the differential of the bracket there. Okay, let's tidy that up a little bit, put that over a common denominator, expand the brackets, collect the like terms. We've got 34 and 15, so that's 49, minus 17 plus 10, that's minus 7, minus 3x plus 4x gives us x. Now we can divide top and bottom by 7, so that's going to be 7x minus 1 over, and we've got a 2 there, take that into the bracket, we're going to get the 12x squared plus 2x minus 4, which is what we had in the original question, so we are correct. Part C. We'll just steam ahead with this one by factorising the denominator. 6x squared minus 1, the factors are obviously going to be 3 and 2, so then we've got to get the ones. We need a minus here, so obviously one has to be positive and one has to be negative. Let's expand this just to make sure it's correct. So 3x times 2x is going to give us minus x squared, 3x times 1 will give us 3x, minus 1 times 2x will give us minus 2x, minus 3x minus 2x will give us x, so that's correct, and then we've got minus 1 times plus 1, which gives us minus 1, that's correct. So we now can look for the two coefficients a and b. Put the right hand side over a common denominator, cancel the denominator on the left with the denominator on the right, so we get the equation minus 8x plus 6 is equal to a brackets 2x plus 1 plus b brackets 3x minus 1. Let x equal minus a half, so this bracket will disappear. So we've got an equation only in b, and you can see that b is equal to minus 4. Let x equal a third, so this bracket will disappear. So we have an equation only in a, and you can see that a is equal to 2. Substitute those into this equation here, just to make sure they're correct. So we've got 2 times 2x is 4x, minus 4 times 3 is minus 12x, which gives us minus 8x, which is correct. And then we've got 2 times 1 is 2, minus 4 times minus 1 is plus 4, 4 plus 2 is 6, and that's correct, as you can see there. So our integral now becomes the integral of 2 over 3x minus 1 dx minus 4 over 2x plus 1. Okay, well, we can probably do this in our heads now, so that's going to be 2 log 3x minus 1 over 3. Don't forget to divide by the differential of the denominator, and the second part is going to be 4 times log 2x plus 1 over 2, because the differential of 2x plus 1 is 2. Okay, just tidy that up a little bit, And there's our answer. Time for a sanity check. Differentiate that answer. We're going to get 2 over 3 brackets 3x minus 1 times 3, because that's the differential of the bracket, and we're going to get 2 over 2x plus 1 times 2, because that's the differential of that bracket. Cancel the numbers that can cancel and tidy that up a little bit, put that over a common denominator, expand the brackets, collect the terms. That's going to be an x there. We're going to get 4x minus 12x, so that's minus 8x, giving us exactly what we started with at the top there. So we are correct. Part D. As before, we'll start by factorising the denominator. Let's just check that that's correct. 3x times 4x gives us 12x squared, so that's alright. 3x times minus 1 gives us minus 3x. Minus 1 times 4x gives us minus 4x, which when added to the minus 3x gives us minus 7x. And then minus 1 times minus 1 gives us plus 1, so that's correct as well. Now we search for the coefficients a and b. Put the right hand side over a common denominator. Now we can cancel the denominator on the left with the denominator on the right, giving us this equation. We'll let x equal a quarter, so that bracket will disappear, and then we can see that b is equal to minus 2. Now we'll let x equal a third, so that bracket will disappear, and you can see that a is equal to minus 2. Substitute the values for a and b into this equation. Just check. Minus 2 times 4x is minus 8x. Minus 2 times 3x is minus 6x. Minus 8 plus minus 6 is minus 14, so that part is correct. Minus 2 times minus 1 is plus 2, same again there. 2 plus 2 is 4, so that's correct, so we can continue. The integral now becomes minus 2 over 3x minus 1 minus 2 over 4x minus 1. So we can integrate those, tidy them up a little bit, and there's our answer. As before, we need a sanity check just to be sure. So we'll differentiate our answer with respect to x. We're going to get minus 2 over 3 brackets 3 minus 1, and then we're going to multiply by the differential of the bracket here, so we'll get 3 times that. And then in the second term we're going to get 1 over 2 times 4x minus 1, and then we multiply by the differential of the bracket, so we'll get a 4 in the numerator there. Okay, tidy that up a little bit, put that over a common denominator, expand the brackets, collect like terms, and we've got minus 14x plus 4, minus 14x plus 4, 12x squared minus 7x plus 1, 12x squared minus 7x plus 1, so we are correct. Part E. Now this is slightly harder than the ones we've seen so far. Notice we've got an x squared term in the numerator. So what we're going to do is we're going to split the numerator into 2 parts. We're going to get the x squared term plus 5x minus 3, because that's the same as the denominator. If I take 5x out of 11x, I'm left with 6x. If I take minus 3 out of minus 13, I'm left with minus 10. So now what I can do is I can take that term away from the other term, giving me 2 integrals like that. So this part is easy. The integral of dx is just going to be x, and this part is similar to the ones that we've been working on. It's a standard partial fractions problem. So now we'll factorise the denominator, and we'll get 2x times x, which will give us 2x squared. We'll get 2x times 3, which will give us 6x. We'll get minus 1 times x, which means that we've now got minus 5x, and that was correct, and that's minus 5x. And then we've got minus 1 times plus 3, giving us minus 3, so that's correct as well. So now we'll look for a and b. such that that equation is true. Put the right hand side over a common denominator. Now we can cancel the denominator on the left with the denominator on the right, giving us that equation. We'll let x equal minus 3, so that bracket will disappear and we'll get an equation only in b, and you can do the arithmetic and see that b is equal to 4. Then we'll let x equal a half, so that bracket will disappear, and we can see from that that a is equal to minus 2. We'll substitute those values for a and b into that equation to make sure it's correct. So minus 2 times x is minus 2x, 4 times 2x is 8x, so 8 minus 2 gives us 6x, so that's correct. Minus 2 times 3 is minus 6, 4 times minus 1 is minus 4, minus 6 and minus 4 give us minus 10, that's correct, so we can continue. So the integral now becomes the integral of dx minus the integral of 2 over 2x minus 1 plus the integral of 4 over x plus 3. That's all straightforward now. The integral of dx is x, the integral of 2 over 2x plus 1 is going to be 2 log 2x minus 1 divided by 2. Remember, you divide by the differential of the denominator, and in the second case the differential of the denominator is 1, so we don't need a division there. And there's our final answer. As before, we need a sanity check, so we will differentiate our answer. Differential of x is 1, differential of log 2x minus 1 is 1 over 2x minus 1, and the differential of 4 log x plus 3 is 4 over x plus 3. Put the whole thing over a common denominator, expand the brackets, collect like terms, and we've got 2x squared plus 11x minus 13, 2x squared plus 11x minus 13 over 2x squared plus 5x minus 3, 2x squared plus 5x minus 3, so we are correct. And that's the end of question 4.